All right, guys, go ahead. Sorry, we're gonna go ahead and talk about the metric system now, and we are going to start off. We're gonna jump right into it, actually. The metric system, also known as the SI system or SI units, that stands for the System International or the International System of Units, is called that because everyone uses it. Everyone except for, hey, those little red countries. All right, we don't use it. This one right here, Liberia, doesn't use it really. And over here, Myanmar. And why don't we use it? I mean, we're the leading country in the world. Everyone else uses it. Why don't we? Why are we being so stubborn? And, back in the 70s, we tried to convert. We tried to uh, move into the metric system with the rest of the world because it makes business easier, communication with other countries to be easier, because we're in a global economy now, right? We need to communicate effectively and it makes all those things easier. So why don't we use it? And the answer really probably comes down mostly to this right here. All right, Mr. Benjamin. So it's an expensive ordeal. You have to spend a lot of money changing all those signs. You have to spend a lot of money repackaging things if you're a business, and that's an issue, right? He can tell you why. There you go. That's an issue. It takes a lot of money, so we never made that move. You see it some areas. You see it as you're going up towards Canada because Canada uses the metric system. So you start to see that. And you talk to a lot of people and they say, "Oh, it's too difficult to use." Yeah, that's not really true. It's actually very simple to use. You don't have to memorize much. In our system, you have to memorize 12 inches in a foot, 5,280 feet in a mile. However many ounces in a pound, or however many pints in a gallon, or whatever. You have to memorize those. In this system, you don't. There's only really one thing you have to memorize, and here it is. You need to memorize this. King Hector Dector used double chocolate milk. All right, say it with me. Ready? King Hector Dector. No, no, no. Come on. Say it with me. Ready? Loud. King Hector Dector used double chocolate milk. What's it stand for? Kilo, hecto, deca, unit, deci, centi, milli. We have a little mnemonic device. You need to know this. King Hector Dector used double chocolate milk. Keep saying it. People will look at you funny. But that's okay. It stands for kilo, hecto, deca, unit, deci, centi, milli. These are the prefixes that we use for the metric system. Some of them you're familiar with. All the way over to the right here, milli as in millimeter, centi as in centimeter. All right, all the way over to the left, kilo, kilometer, kilogram, right? All those things. Some of them are a little weird and you may never use them, but you need to know them because it goes in order. This big blue one in the middle, unit, that stands for something a little bit different. What that stands for is this stuff down here. Um, in our system too, we have units. You don't measure the distance from here to Rutland in pounds. You measure it in miles. Well, same thing in the metric system. You measure length not in miles, but in meters. You measure mass in grams. You measure time in seconds. You measure liquid volume in liters. That's why you go buy a 2 liter bottle of whatever. So that's what the unit stands for. It's the meter, the liter, stuff like that. Here's our three most common units that we're going to use: meter for length, liter for volume, grams for mass. And up top there, I've used my mnemonic device, kilo, hecto, deca, king, hector, dector, used double chocolate milk, unit, deci, centi, milli. And I write this thing out. And I encourage you guys, it doesn't have to look this fancy, but to write something out like this when you get faced with a problem. Because this is going to help you convert. And this is where it actually gets very, very simple. You've done the hard part. You've memorized the prefixes. Now for the easy part. Let me give you an example here. Let's say you have a length of 5 kilometers and you want to convert it into meters. How many meters is that? You don't have to memorize anything except for what you've already memorized. Now you just plug things in. You take this 5, since we're dealing in kilos, we're going to put it under the kilo here, 5. The decimal, even though we don't write it with a whole number, it's there, right? Whoops, get rid of that. It's there. There we go. Now, we're going to move to the right to our base unit, the meter, right here to the unit. Every time we take a step to the right, just like walking up stairs, we're going to move the decimal to the right. You move to the right, the decimal moves to the right. So this becomes 50. This becomes 500. And this becomes 5,000. So our answer, 5,000. See how I did that? Every time I went to the right, the decimal moved to the right. And so I just went from the kilometer, km, which is 5 kilometers is equal to 50 hectometers. 5 kilometers is equal to 500 decameters. We do DAM because we have another D over here, which is just going to be the decimeter, DM. This is just our plain old meter. There's our decimeter, centimeter, millimeter. Don't confuse the millimeter, mm, for the meter, just one M. Okay? And that's all you have to do. So let me give you, I want to do a couple other examples. Let's do another one here. Let's say you have 2.3 decimeters, dm. If it was DAM, it would be the decameters. This is decimeters. That's equal to how many hectometers? So take my 2.3, put it up here in the deci, 2.3. I'm going to go to the left this time, so my decimal moves to the left. Here it becomes 0.23. Here it becomes 0.023. Here it becomes 0.0023. Whoop, that's not 3. 3, there. 0.0023 is our answer. Let's do 2 more examples. I want to do these examples just for practice and to show you that we don't always use meters. If we're not doing length, let's say we want to do mass. I can say, okay, I have something that has a mass of 120 DAG, that's a decagram. So I just get rid of my meter and I put in a DAG for decagram. And I want to know how many grams is that? This is going to be an easy one. So I put my 120 right here. My decimal's right there. I'm going to move one spot over here to where the gram is, the base unit. So one spot to the right, decimal moves one spot to the right. Answer, make that better too, 1,200 grams. One last example, 20.1, that's supposed to be a point, centiliters, CL. We do a capital L when we do liters, and a liter is just usually a liquid volume, and we're going to figure out how many kiloliters that is. So my centi is still my centi here. It could be a centimeter, centigram, centiliter. Doesn't matter. My answer is going to be the same no matter what it is. But I'm going to put my 20.1 there. I'm moving to the left, so the decimal moves to the left. So it becomes 2.01, 0.201, 0.0201, 0.00201, and here we are at the K, the kilo, 0.000201. There's our answer, 0.000201. You notice how when we move to the left, the number always gets smaller, and when we move to the right, the number always gets bigger. All right, that's a pattern that you should be aware of. So that is how you do it, and we're going to do some practice on this. I think you guys will, towards the end here, hopefully feel like this way is actually quite a bit easier than the way that we grew up with. All right? Now, these are all dealing with single units, the meter, the liter, the gram. I want to talk for a moment now about these things called derived units, when you have 2 or more units put together. And the example that we're going to probably talk the most about this year is, you probably have done this before, density. Density has 2 units. Right? It has the unit of mass, there's 1, and the unit of volume, there's your 2 units. So mass can be in grams and volume in liters, so you have grams over liters. So if I get a density of 3, I put grams per liter, or grams over liter. That's our density. Here's the formula down here in a shortened up version. D equals m over v. You should memorize that as well. We're going to use it a lot. I have a feeling a lot of you already have that one etched into your brain from years past. D equals m over v. And density is a pretty important concept in earth science and all the sciences. It's basically just something that tells you how tightly packed together something is. And I'm going to give you a few examples here. This is aerogel. Aerogel is a very, very cool product. You should look this up and research it more. It's a extremely low density material. And what they do is they take the gel, and you could think of the gel as being made from maybe equal parts of solid and liquid, and they go through a process where they turn the liquid part of the gel into air. So what you end up having is this solid and air gel, so they call it aerogel. Extremely low density, and it's a very amazing product. Expensive too. That right there is a very expensive handful that that person has, probably, hundreds if not thousands of dollars. And it's also an amazing insulator. They say, I once heard this, I don't know if it's entirely true, but that if you were to insulate your whole house in just a half-inch of aerogel all around the walls, you could heat the inside of your house with a candle. Wouldn't that be amazing? All right. It'd also be the most expensive house in the world. The most expensive insulation. So that's a very example of very low density. Here's an example of high density. That's mercury, liquid mercury, and it's so dense. The particles in that liquid are so tightly packed together. It has such a high density that you could float solid coins on top of it. So there's just kind of an example of the extremes on one end and then on the other. And I want to also talk about a way that we can mess with that formula, D equals M over V. Like, what if I know the density of this mercury, and I know how many liters I have? Can you figure out what the mass is? If you know the D and the L, can you figure out the M? And yes, you can. Here's your formula. And this is a little tricky way of doing it. This could be very helpful, I think. D equals M over V. So think of it like this. If I have D right here, it's equal to M over V. D equals M over V. Let's say I give you a problem. I say, hey, here's the density of the material. Here's the volume of the material. Can you solve for M? So you say this, M equals, now they're side by side. That means they're multiplying each other. D times V. Okay? That little dot there means times. Or let's say I know the mass and I know the density. Can I solve for volume? Yes, you can. V equals M over D. That's an easy way of manipulating a formula. It only works, typically only works with a formula that only has 3 variables. There's ways of kind of tinkering around with it to make it work for others. And it definitely only works if you're multiplying or dividing. But we'll talk more about this in class, and we'll practice all this stuff in class in our upcoming lab. And I will see you then. Bye-bye.